Okay, here's how to answer a typical amplifier question, a voltage amplifier question. First of all, you'll usually get a graph like this, which shows the input and the output voltages. Okay, so you need to look at this graph very closely. First step is to calculate the voltage gain by looking at the gradient of the graph. So you'll see a linear section of the graph here, where you've got a certain output voltage for a certain input voltage. So the voltage gain is simply the rise over the run, or the amount of voltage out compared to the voltage in. Now look closely at these graphs. The voltage in is quite often in millivolts, which is 1,000th of a volt, so you need to convert that to volts. And the output is normally in volts. Okay, so you'll typically get a voltage gain that's reasonably significant. You'll get a ratio figure once you've calculated that gradient, which gives you the gain or amplification of the voltage. The second thing to look at is the gradient positive or negative? Is the gradient going in that direction, which is positive, or is it going in this direction, which is negative? In this case, it's going in a positive direction, so the graph is non-inverted. The output signal is non-inverted. If it was a negative gradient going down this way, it would mean that the output signal is inverted or 180 degrees out of phase with the original signal. And that's important for when you draw the graph later. And lastly, you've got to look closely at the range of the input signal. Notice these flat sections here and here. That represents the limit to the input voltage that's possible with this particular amplifier. And in this case, you see that if you get more than 10 millivolts coming in, you hit that flat section of the graph and the output voltage is no more than 4 volts. So you've got to look closely at that range and find out where the output is flat. If when you're asked to draw these graphs, as you are in question 11 here, draw a graph of the output, you need to consider whether this input signal lies within the linear range, in which case it's not clipped or distorted, or whether it continues beyond the capability of that particular amplifier and goes into the clipped range. In this case, the input signal is between 5 and minus 5 millivolts, so the peak input is 5 millivolts. And you'll see here from this graph, if the input's 5 millivolts between minus 5 and 5, that's still within the linear range of the graph. So this particular signal is going to be non-clipped. It will be a full signal, so you can draw it as a full output signal in phase with the input signal here. So all you need to do to answer this question is to look at the input voltage and then apply the gain. So look at your peak voltage, input voltage here, multiply it by the gain or the amplification to get your peak output voltage here. This particular one is a positive gradient, so it's non-inverted, so it'll be the same shape as this one. And then you can simply draw the graph here with the correctly labelled peak voltages. So probably use that section there to draw your peak output voltage in this case. So that's basically how you do these problems. If it is clipped, obviously you need to stop the signal at the maximum input value and then draw it flat across at whatever the maximum output voltage is. Make sure you label the axes clearly and have a good scale. Label the maximum, the minimum and the clip values on this part of the graph, the voltage output. In terms of the time, it's just in the same time period as the input signal. Make sure you clearly label the graph, and in the sections where it's not clipped, be careful to draw the graph as a curve, as though it would be a sine curve, until it gets clipped, and then you can draw a flat line. But try to draw the curved lines between the flat lines. They're not straight lines. It's just the original signal which is amplified correctly until it hits the limit. in which case it's flat and distorted. Okay, so that's that particular question, and you can follow up by answering this question on clipping, which I will deal with in the next video.